Today we're going to try something really crazy. 23.9, close enough. These are very close to true O scale. You don't want to try this with a modern transformer. So this is based off of a real B&O caboose from 1916 up to 1938. That is not helpful. Now it is truth or consequences time. Part of the circuit is running through this wire arm here. Very simple but effective animation for the layout. Hello again, this is Mike with Toy Train Tips and Tricks, and today we're going to take a closer look at these 3D printed trucks for O27 trains for Lionel, Marx, whatever. 3D printed from scratch and show you how it's done. So this is a batch fresh off of the printer. This is off the build plate. It's removable from the printer. And so you see all of the parts necessary for one complete truck. And so we'll walk through the steps from here to having a truck ready to go on our rolling stock. So the very first step is to take our little spatula, and we're going to pry these things off of here. And it helps if you have your supplies ready to go. So I've got my little print spatula, and basically I'm going to go underneath these. And this one I really need a new print cover, because this one is starting, there we go, to get where everything is sticking to it, even when the print height is set right. But give it a little twist, and you heard some things pop there. So I'll come back as soon as I have these off. Okay, so after scraping off the bed, this is what the parts look like when they come off. There is this extra layer that I put on here. This is called a brim, and this is just one thin layer of the print. And the idea is that that goes down first to the print bed and gives the rest of the item, the rest of the print, something to stick to so that it doesn't fly around. And I found that most important with the round wheels because it starts from the inside out, and if that very first part does not stick to something, then you soon have a big pile of plastic spaghetti on your build plate instead of wheels. So it does use a little bit more plastic, and you've got a little bit of cleanup to do. But without this, I was having a success rate of about 50% on the wheels. And with the brim, 100% of them print. And then same thing with my axles here. You see it's kind of a small part. There's not very much of it actually touching the print head. And so as thin as it is, so without that brim, this thing would just slide around and it wouldn't print properly. So that's one of the things you do. This is still using the generic PLA. I was hoping to do a print in some PET G, but I went to my local supplier and they are out of PET G in any color that would be reasonable for a truck, and I really don't feel like painting them. But I could print them off in neon green if I wanted to, but not in black or brown or dark gray or anything resembling a railroad truck. So we're still in PLA. So my first step is to get this stuff off. Some of it just peels right off, and dispose of that. That one's pretty good. So some of them just peel right off. Some of it you have to cut a little bit or sand. And this, nothing's going to be touching this part of the axle, so I'm not really concerned too much about this flash. That's just cosmetic. But I want to make sure I get it all off of these points, because this is where the wheel is going to be. All right, so I've got my axles clear. Throw that in the trash. All right, let's do the trucks. And this one is the hardest one. And it has to do with something in printing we call supports. And to me, supports are kind of like the government. That which supports best supports least. And once you get supports into your print, it's hard to get them out. So part of the engineering that goes into making these is figuring out how to arrange things so that you have as little to clean up at the end as possible. So certainly with this printer technology, I could make it so that the whole thing printed in one piece, but because of the geometry of, for example, I've got to clear that off first. There are horizontal pieces and vertical pieces. So if I printed it as one piece, like so, this would be fine. Well, get it in the camera range. But when you come across here, there's nothing underneath it. So you need to add supports to hold this up. Otherwise, it's just going to drop the plastic all the way down. And like I said, the more supports, the harder it is to get it out. So I'm finding it easier to break this up into lots of pieces that I can have print on their backs. And it also allows me to do more detail here on the trucks. Okay, so let me get this other truck frame here and show you what's involved in cleaning these up. That one's sticking a little tighter. Okay. Now, on the back side of these with this design, there's a hidden surprise. In order to attach to the truck bolster, this part here, I have a rectangular indentation. But again, since this prints on its back, there is a support that prints in here. And so when I'm done, let me take a bigger one, a slotted screwdriver, slide right down in here, and voila, my support is gone. There's my rectangle. It needs to be cleaned up a little bit. So again, I'm going to take the edge of my slotted screwdriver and just clean up that edge a little bit, because it is a tight fit, as you would hope, with the truck bolster to keep everything together. Same thing with the other one. Pop out our surprise compartment in the back. Now when I print these, most of the time when you're doing a 3D print, the inside will be somewhat hollow, and you'll use what's called infill and type of a zigzag pattern that provides a little bit of structural support but basically saves plastic. In this case, because one, these parts are small, and two, I wanted them as strong as possible. It's very important in my rail car. And thirdly, they're not using a whole lot of plastic anyway because it's small, and I wanted to maximize the weight. I printed these completely full, what's called 100% infill. So most 3D prints, you slice them open and there's a webbing inside and hollow spaces. These are solid pieces all the way through. Okay, so I got that cleaned out. Let's get my file, clean out my axles. Now, as with any modeling material, there are compromises that are made with the 3D printing process, just like there would be if I was making it out of balsa or out of styrene or whatever. And there's always a compromise between detail and function and what's best practice for using the particular medium. And so, as I made these truck side frames, there's quite a bit of detail, but my earlier versions had more detail, at least on the screen. But again, in the process of actually printing them and dealing with supports, they came out not as nice as I wanted to. So I backed off a bit on the detail in favor of ease of printing and ease of preparing these for actual use on the layout. So one of the things, for example, on the springs, there really should be 3 springs across here, and earlier versions had that. And the original springs were more rounded. These are flattened down somewhat. And again, this was just trial and error. I found this design was easier to clean up and get layout ready without spending nearly as much time cleaning up the nooks and crannies that I had to do on the ones that had more detailed springs. So it's a matter of close enough, especially as the car is running by in typical Lionel speed. Most people aren't going to have the opportunity to stop and count, well, how many springs are there in that truck? I consider this more of an impressionism, that it looks like a modern, Bettendorf freight truck. It's not exactly, but it's close enough for our model, for our toy train world especially. Okay, so that one's looking pretty good. Now let's move on to the wheels. And the wheels, again, we've got this brim to take off. Generally, it just peels off. All right, and normally I would keep going here, but my old hands are starting to cramp and get numb, so I'm going to take a little break. I'll be back in a moment. Okay, so to save time on the video, I've gone ahead and I've cleaned up these 3. I've got one more wheel to go, and just to show you how, there's this little bit of flashing left from the brim, and so I'm just going to take a file around that to get those stray pieces that didn't want to come off before. You don't want to file anything flat. Although if it's slightly out of round, it's not a big problem because it's the flange, not the wheel itself. So you're safe if you get it on, if you file a little bit too much off in one spot. It doesn't have to be perfectly round. And let me take this one around that spot, and then let's ream out the middle. Let's reduce friction as much as possible. Okay, and that looks pretty good. Okay, and that just leaves the truck bolster and coupler assembly, and this prints upside down. And here's an example of the supports. Here's the brim, and well, one support already came off. The other one is there. That supports that as it prints upside down, because if I turned it this way, all of this would need support and would be a real pain to take off. So instead, I print it upside down. The downside is this isn't as pretty. I lose some of my detail on top because it's stuck against those, against the build plate and against the brim, and all of it doesn't necessarily want to come off. A little file to the top here, the bolster. I want to make that as smooth as possible because that could be friction with the body of the car. Okay, it doesn't have to be pretty, just has to be decently smooth. Okay, and I also check for any flashing around the edges here because this part will fit together with my side frames. So make sure everything came off cleanly there. Okay, so I've got my wheels, I've got my axles, I've got my side frames, I've got my truck bolster. Now, this next step, again, my goal is to reduce friction as much as possible with this plastic. So there is a technique that I use here before assembly. I'm going to show you now. This is a wheel that's already been done. And one of the disadvantages in 3D printing is you can always see these lines as things go together. So let's look at here on this one. You can even see a little checker pattern on there. and especially on the back side. Oh my goodness, look at the back. So this one has been done, and compared to this one, visually, it doesn't look a whole lot different. But when I feel it, I can feel that this one that I've done this treatment on feels smoother. And smoother is good. Smoother is less friction. So what I do to these next, there's a process that gets used with some of these that folks call vapor smoothing. There's a chamber and a pump is full of a mist made basically of acetone, and it seeps in and it smooths out the plastic. You get it virtually as smooth as glass. Well, it takes a special chamber to do that and such, but what I'm doing is the same concept, and I'm going to show you in just a second. Okay, so this acetone smoothing, it can also be done with lacquer thinner, and I'm going to pour just a little bit of lacquer thinner into this container. There we go. It should be enough that I can take my parts and dip them. Whoops. I want that to go the other way. Actually, it's going to take a little bit more. And of course, in a well-ventilated area with all the safety precautions. There we go. Okay, we'll put that in there. We'll put a second one in there. And we're going to keep these in here for about 30 seconds, maybe 45 seconds. Let them sit there for not long. And let me use the file to get these out. Woo! And I'm going to lay them on the towel, and I'm going to let it sit there overnight, 24 hours. And what happens is the acetone or the lacquer thinner, or there are some other solvents you can use, MEK, if you can still find it, works, but it's a lot more toxic. So this softens the outer layer of the PLA, kind of melts it a little bit, and by laying it down, gravity takes over and kind of smooths it down, but it also softens it. So the disadvantage of that, and here on the axles, I'm just going to dip the tip. Again, I want to make it smooth to reduce friction. I'm going to lay that in there. So as it affects the edge, it takes those ridge lines out. It melts them, softens them a little bit. They drop down and smooth. Let gravity, like liquid finding its own level. That's what I'm looking for. Like water finding its own level. And so it makes that edge smoother. It also makes it softer temporarily. So if you let it sit overnight, it gives the chemical enough time to do its business. And then as it evaporates, the PLA rehardens to its original form. I'm going to do the side frames here too, clean those up a little bit. Not really going to worry about the bolster. I'm going to set that aside. Let the trucks in there, they're a little bit bigger. Okay, that ought to do it. And like I said, there's a little bit of a visual difference, and if you coat them over, if you do it enough, if you coat them 3, 4, 5, 6 times over the course of a week, they will significantly smooth out. But what I'm looking for is just get it smooth enough that it feels, and you can feel it already. You can't see it, but you can feel that it's a lot smoother, less friction, and we're talking about wheels and things that roll, so the less friction, the better. Okay, so I've cleaned up my mess. So these items are going to sit here and dry out overnight, and in the morning they'll look like this, and then we will be ready for the next step of assembly, of press fitting the pieces together, adding a little bit of your favorite super glue, and we'll attach them to a car, put them on the layout. So see you tomorrow. All right, well, it's now morning. Time flies when you're having fun, right? And so just to reiterate, this process that I did overnight using the solvent to smooth out the PLA plastic, it's totally optional. The only reason I did it, well, 2 reasons. One, it does make a slight visual difference in smoothing out the PLA, but it does make a difference that you can feel. You can feel how the solvent has smoothed out the surface, which should help reduce our friction in the truck quite a bit. This might not even be necessary with other filaments, such as ABS or PETG, that print at higher temperatures and therefore smooth out a little more than PLA does. But haven't tried that yet, as I explained earlier. So they've sat overnight. Everything's nice and hard and dried out. So let's continue with the assembly. So next I'm going to take my bolster and a side frame, and this snaps together with a little bit of encouragement. It is a tight fit. It is meant to do that. Come on. There it goes. And fits on there quite snugly. And I just want to test fit the other side just to make sure I don't have any additional sanding or filing to have to do. Okay, so it's a good solid fit on there with a press fit, and it would probably work like that. But just to make sure, when I put the axle together, I'm going to put a little dab of, in this case, Loctite, but use your favorite super glue. Just a dot on either side will hold that and keep it from popping out. So I'm going to take it back apart, and I'm going to start with my glue. It's like I need a new bottle here. There you go, just a dot there, a dot there. Let's put it together. Make sure it snaps into place. And with this, the slower acting the super glue, the better. That gives you more working time, just in case it doesn't line up right the first time. Okay, so that is firmly in place. Now we are going to add our axles and wheels. So we take our axle, run a wheel on here. Sorry about that. I was interrupted, but let's go back to where we were. We had this one already glued on, this side frame already glued on. We were attaching axles. These spin nice and freely. That one more so than this one. Okay. Let me loosen that one up a little bit more. That feels a little tight. And we're just filing down the inside of that hole just a little bit more. Oh, that's much better. Okay. Sit it in there. And I'm going to use this tube here to hold everything vertical. Check this one. That one's still a little tight. File it one more time. Much better. Much better. Okay. And slide that in there if I can see what I'm doing. Hold it vertical. And now the fun part. And then I need to line that up with this while I pop this on and glue it in place. And again, the more working time you have with your super glue, the better. This one, unfortunately, is kind of fast. I need to get a slow-acting gel to do this on a better scale. Okay, so I've got one axle in. I've got one axle really close. I'm lined up with the bolster, and when it pops together, aha! Ta-da! And we have a complete rolling wheel set. All right. And as I said, it pretty well holds itself together with friction, but the glue is there to give it a little bit of encouragement. So I'm going to let the glue set up. Then I'm going to come back and give a little bit of oil on the axles, but there pretty much is your complete truck ready to go. Now the hole here is designed as 5 millimeters. In actuality, as the plastic expands, it actually comes out to about 4.5. So you could use a 4 millimeter bolt, 3 millimeter bolt, or a 1/8 inch machine screw, which is about 3.5. Slides right in there, and use different lengths depending on what your need is with the particular car, and put a bolt on top. And one thing I did find in later experimentation was, as I put it in the car, I just laid a couple of these flat washers right around the bolt on top of the car. I just taped them in place, and just that amount of weight on each truck improved the tracking capabilities of these immensely. So, so there it is. This one is ready for installation on a car, in a caboose, on a tender, and so there it is. That's how you print them and how you assemble them. So as always, I hope you found that useful and helpful. And if so, please like, subscribe, share, tell your friends, tell your neighbors. Keep the trains rolling, and we'll see you next time on Toy Train Tips and Tricks.